percent of change, again, the big part of this, I'm not normally a huge write out the definition guy, but there's a couple of words in here that really kind of help doing this and getting things into the right places. So it's actually helpful here. So a percent of change is the percent that a quantity, an amount of any sort of whatever it happens to be, increases or decreases. And then here comes the important part. And we're going to color code this a little bit. When you're doing a percent of change, whether it's getting larger or smaller, everything is based on what you started with, not where you end up with more or not where you end up with less, but compared to, hey, from where did I come? That helps me determine if I'm going up or down, increasing or decreasing, and it also helps me to make sure we're all talking about the same amount. So the best way I can think of to do this probably is going to be with a proportion like we're going to set up here. So we're always going to set up as the amount of change, which will end up being positive. We'll know whether it's going up or down to know the decrease or increase part. Over however much we started with. I mean, it can be money, it can be people, it can be stuff. And that's going to give us our percent of change over 100. Now, again, most of the time, since the percent of change, almost always for what we're going to be doing here, is going to be the variable, what we're trying to find, plus that'll end up being our x. Now, is it possible they could tell us the percent of change and we have to find one of these other pieces? Yes, but more times than not, that's where our x is going to end up. So, if we have a percent of increase, percent that the original amount increases by, you're like, well, duh, that makes sense. And so when we're looking at these, this proportion we're going to put here is just going to be a little more specific than this one. This one's a little more flexible. So we're actually going to write down what the math work is that we're going to do here. So we're going to take the new amount minus the original. So a little bit of math work to do before we even do the math work. That's kind of interesting. It'll make more sense when we start putting numbers in here in a minute. And we're going to divide that by the original amount. So again, the number on top will end up usually being smaller than the number on the bottom, but we never know. And then the second fraction is going to be the same. So there's a couple of places that we're going to have to do some work before we're going to be ready to set this up and get prepared into our answer. But that's why we always have this nearby, just to kind of get us a head start here on what these are all going to look like. So, move that up just a little bit here. So as you're getting that finished up, we'll read the problem below here. Catherine buys t-shirts for her clothing store for $20. She sells them for $45. Find the percent of increase. Okay. So here, the new amount that she's selling them for is 45. Minus the original amount that they cost her, which would be 20. We're always going to divide by the original. So that would also be 20, and these will always be the same. And then we're trying to find the percent of increase. That's the mystery. So, like we'd mentioned up above, that is typically going to be our x. I like that sound. I'm hearing the calculators out and flowing here. 45 minus 20 is 25. So we'll get that simplified a bit here. Little cross multiplication. Do not trust my brain for the math right now. Now that seems a little bit odd because sometimes we talk about like catchphrases like, hey, give 110%, even though really you could only give 100. You're like, really? You know, have a percent of increase that's over 100. You can. That just means she's charging more than double what she paid for. So it was 100%, it'd be her original plus that amount again, which would be 40. So yeah, when the original is smaller than the new, it's going upward. You can get some numbers that are over 100. It won't be every time, but it's possible. So the only other difference we're going to see then in the percent of decrease, we're going to I want to keep that original, there we go, is going to be it is the slightest difference. When you first look at it, when we get done putting it down, you're going to think we basically wrote the exact same thing that we did up above. But we didn't. There's one slight difference. When we're looking for a percent of decrease, instead of doing the new amount minus the original, we're going to do the original minus the new amount. That takes into consideration that it's going down in value. Could I still possibly get to the right answer if I did it the other way? Yes, but it's going to look really weird. Okay, we'd have to make one other adjustment. So we'd rather just get the stuff in the right place the first time. So if we're looking at that, so I look and I'm like, all right, let's see here. There were 10 students who were semifinalists in the science fair. The judges selected 7 to move on to the finals. Find the percent of decrease. Okay, so there were, originally in the semifinals, there were 10 students. But we only selected 7 to get to the finals. And we're looking for the percent of decrease. So labeling can help too sometimes if you're not sure on something. But always looking for the words decrease or increase right in the problem can be helpful. So we got our original 10 students minus our 7 students that are going to get to the finals, divided by our original. That was the same in both. And then we don't know the percent of change, in this case decrease, over 100. So 10 minus 7 is 3. And just a little cross multiply here. If we divide, it looks like we lost about 30% of our competitors. Now, as I was mentioning back at the beginning, this is going to be the same setup for all the ones we use. The only thing that may change, and we'll take a look at a couple of the practice ones to see where that might occur. A couple of these values in here might change into our x value, but we're still going to use a proportion, so we're still going to solve it the same way. So it shouldn't end up being too bad of a deal. So let's, mentioning that, let's pop to the practice here. We're going to do a couple different things, so I want to make sure that we've got this. So here's whenever I see percentage of change problems, I would make a suggestion. I would go through and see if they're talking about increase or decrease in each of the problems, because if they are, that's going to help me figure out which of the forms I want to use. But the one I want to take a peek at on this page is the very last one. My 7 got cut off there. I'm like, it looks like page 21. It's really page 27. Last month it took Lucas 32 minutes to run 3 miles. This month it took him 28 minutes. Find the percent of change. Now it didn't say increase or decrease. So how would I figure out which one it is, or which one is it if you think you know? Is this going to be increase or decrease? Okay, and I'm with you. If you're not sure, here's kind of what you'd want to do. And I'll be back to this problem. I'm just going to show one thing up here at the top. So notice on the increase, we started with 2, we went to 5.5. It got bigger, it increased.
It decreased.
Right, well, this one increased, but you're right. Down here, just like this one, it went from bigger to smaller. It decreased. It went from bigger to smaller. It decreased. That's true. So if they don't directly tell you, that's how you can figure it out, okay? Did the number I'm looking at go down or up? And that's all you really have to do. The other twist, actually, do I want to, let's do this one while we're here. Can't leave people hanging. So again, if we're doing that one, we're doing the original 32 minus the new 28 divided by the original. Okay, we should not end up with negatives up top if we do things in the right order. And the percent of change, whatever it is, whether it's increasing or decreasing, will always just be x. So the setup on these shouldn't be too bad. Now let's see though. I'm feeling a decimal coming on here.
It's not that bad.
Not a bad one?
No.
Well, that's good.
It's nice decimal.
That is a nice decimal. So Lucas decreased his time by 12.5%. Not bad. That's not bad, especially for a month. Yeah, that's some good progress. So that's what we're kind of taking a peek at here. Now, when we turn though, because I've got one more piece of this, because I'm setting this up for, like, I don't want to call it necessarily a project, but we're gonna do some fast food comparison pricing with percents of change, and we're gonna be in shock Monday, but we'll get to that then. So this next part, as you start to flip, you're like, wait a minute, now what's going on? I'm seeing stuff and dates and all these things. What am I supposed to do with these? These things on 29 and 30 are to help us over on page 31. So let me kind of give a little guidance here. So no work on 29 and 30. It's all for the 31 stuff. So let me, for at least for your sake, turn this sideways for a minute. So in 1977, man, almost made it back to my birth year. A loaf of bread was a quarter. Okay, it was 25 cents. A dozen eggs was 59 cents. Today, and again, some of these prices are even probably a couple of years old, so we might not be quite accurate, but we're getting there. Today, $2.49 on the bread, $1.99, maybe. Sometime on the eggs, which price had the greater percent change. That one I could probably look at and tell you and just look, but we're gonna do this correctly. So let's see if I can. Ooh, I think I can. Maybe. Can I get the whole thing in the page? Oh, look at that. All right. So our percentage of change on our loaf of bread, I can definitely see it's an increase. Definitely is not decreased. So again, when we're looking at these, let me pull this back out too. Definitely an increase. So we're doing the new amount minus the original. Divided by the original. Like, Hardy, where in the daylights am I even supposed to put the answer? I know. I should have been better about this. All right. So there's a difference at $2.24. If you're going to try and put the whole thing in the calculator at once, since we're getting decimally here, we got to make sure we put parentheses around the top. Otherwise, the calculator's going to do weird things. So, oh, should I have done it that way? Probably not. Hardy, give yourself a sticky note. Why are you doing the sticky note, Hardy? Because this just happens when I do silly stuff. I will find some more paper as well if you want to be able to do your work. Well, I guess we could do it along the top there. Do my cross multiplying. And then we're going to divide by the side going with x. Woo! 896% increase. Okay. That's a little wild. For our dozen eggs, let's see here. So we still got new minus original because it's an increase. First I thought a dog had gotten loose in the building. Then I was listening closer there and I'm like, nope, that's just a cart that really needs an oiling. Okay. Yeah, this is going to be one of those days, I think. And I did it again. $1.99 minus 59 cents. Okay, it's $1.40. So let me get my handy dandy here again. Like I said, if I need to locate us some paper, I will do so. So 1.4 times 100 be 140 equals 0.59x. So we got to divide. Oh, holy decimally. Let's just go to the nearest whole on these. And the loaf of bread will be our winner. The loaf of bread. Stick to the proteins, stay away from the carbs. I guess that's the story here. So that's what we're going to be doing on this thing with the tasks. things. Calculate them, see which one is greater, but actually calculate them. I know that one you could kind of eyeball and it wasn't going to be too hard. But play with the tasks and doing those. That's going to give you a real good start for, like I said, Monday we are going to break down McDonald's, where it has been and where it has gone. Just price wise. Nothing out there on the food quality or quantity here. Just that. So